Hello everyone, myself Sindhushri MV, Assistant Professor, Department of Mathematics, Maharaja Institute of Technology, Mysore. In the previous class, I explained the indeterminate form 1 power infinity. In the continuation of that, I will take the next example, that is second example. The limit of cos x power 1 by x square as x tends to 0. So first you apply the limit for the given problem. So as x tends to 0, the cos 0, the cos 0 is 1, 1 by 0 is infinity. So the given indeterminate form is a 1 power infinity. Then as usual, you consider the given term as y. The solution of this, let y equals cos x power 1 by x square. Then take the log on both sides. So log y equals, apply the property log a power m, it is m log a, so 1 by x square log cos x. The given the limit x tends to 0, apply the same limit. Limit as x tends to 0, you can write the LIM or LT, both are same for the limit. Limit of x tends to 0, log cos x divided by x square. Soon after this, apply the limit as x tends to 0. So, the cos 0 is 1, log 1 is 0, denominator x square you have. Then you can apply the L'Hospital rule by L'Hospital rule or simply L rule. Can take the L rule or L'Hospital rule equals limit of, the L'Hospital rule means you have to differentiate the numerator and denominator separately. Log cos x differentiation 1 by cos x, then cos x differentiation minus sin x, denominator x square differentiation 2x. Then rewrite this term, the sin divided by cos x, the limit of x tends to 0, write the sin divided by cos is minus tan x divided by 2x. As you know the property, the limit x tends to 0 for tan x divided by x, this part as limit x tends to 0, this equal to 1, apply the property, and the LHS side you interchange the log and the limit. Since you have the property, you can interchange the log with limit. So the property is, you can write, using the property you can write log with limit of y as x tends to 0, this equals minus 1 divided by 2. Since you know the property of the limit tan x divided by x as x tends to 0 equals 1. This is the reason. This you studied in the last class, the tan x by x limit as x tends to 0 equal to 1. Then limit y as x tends to 0 equals, since you have the log with base e, you can take the to RHS part, you will get the e power minus 1 by 2. You can write this term 1 by e power 1 by 2, or simply it is 1 by root e. Starting y you taken it as, it is log cos x with the power 1 by x square as x tends to 0, this equals 1 by root e is the answer. This is the problem. Third one, limit of 2x plus 1 divided by x plus 1 power 1 by x as x tends to 0. First you apply the limit as x tends to 0. So the first part is 0 plus 1, you will get the 1, denominator is also 1. So it tends to 1 by 0 is infinity. So the given problem tends to 1 power infinity. Then apply as usual, you have to take the first term as y. Let y equals 2x plus 1 divided by x plus 1 power 1 by x. Then apply the log on both sides or take log on both sides. So it is log y equals 1 by x log 2x plus 1 divided by x plus 1. Then they given the limit as x tends to 0, then apply the limit on both the sides. Limit x tends to 0 log y equals limit x tends to 0. Here again you apply the logarithmic property log m by n. So log n by m can be written as log 2x plus 1 minus log x plus 1, denominator you have x here, so write that x. Then apply the limit, check whether it takes the 0 by 0 or infinity by infinity. So if first term log 1 minus log 1, you will get the 0 in the numerator and 0 in the denominator. So the given problem is reduced to 0 by 0 form. Then apply the L'Hospital rule to the RHS bar. By L'Hospital rule, for the LHS part, limit of x tends to 0, differentiate the numerator and denominator separately. So the first one, log x differentiation 1 by x. So 1 by 2x plus 1. Differentiate 2x plus 1, you will get the 2. Second term, log x plus 1 differentiation 1 by x plus 1. Differentiation of x plus 1, you will get the 1. The whole denominator, the x differentiation is 1. Limit as x tends to 0, the first part, you will get the 0 plus 1, this is 2 minus 1. So the total answer, you will get it as 1. In the left part, you interchange these two, log with limit. Since you have the property of this, you can interchange these two terms as x tends to 0 like this. Since you have the log with base e, write this limit y as x tends to 0. You take this part to RHS side, you will get the e power 1, that is simply e. Starting you taken the y as the limit of 2x plus 1, denominator x plus 1, power 1 by x as x tends to 0. This answer is equal to e. This is the answer. Next problem. Limit of cot x with the power sin 2x, both are trigonometric terms. So apply the limit as x tends to 0. Cot 0 is infinity. We will get the infinity. Sin 0 is 0. So the given indeterminate form is infinity power 0. First, as usual, you take the given term as y, take the log on both sides, then apply the limit, then convert into standard indeterminate form, then you will get the answer. So the first one, first I take this term as let y equals cot x power sin 2x. Then take the log on both sides. So left part it is log y equals power, since you have the power, log a power m property sin 2x log cot x. Then apply the limit. Limit as x tends to 0, log y equals limit x tends to 0, sin 2x log of cot x. Here you have the sin 2x. Since you have the sin 2x, you multiply and divide by 2x for the numerator and denominator, like this. You know the property of limit x tends to 0 for sin 2x divided by 2x equal to 1. So the problem is reduced to some another indeterminate form. So when you check that this tends to 1, then the reduced form of this problem, it is 2x log of cot x. Again apply the property, limit as x tends to 0, cot 0 is infinity, the log infinity is also infinity. So this part 2x 0 into infinity form. So the indeterminate form takes the 0 into infinity. If it is infinity into 0 or 0 into infinity, write any one of the term to the denominator. So I write this x to the denominator, limit of x tends to 0, 2 you keep it as it is, log of cot x, take this x to denominator 1 by x. So the reduced indeterminate form takes another form, so it tends to infinity, cot 0 is infinity, log infinity is also infinity, 1 by 0 is infinity. So it tends to infinity by infinity form. Then you can apply the L'Hospital rule easily. So it is the limit of x tends to 0. First you keep this term as it is, log cot x differentiation 1 by cot x, differentiate cot x minus cosecant square x, denominator 1 by x differentiation minus 1 by x square. This limit as x tends to 0, this 2 you keep it as it is, then write the tan x 1 by cot x as a tan x, write the cosecant as the sin square x, take this x square to numerator, there is a term. As I already said, whether you have the sin x or tan x in the problem, try to apply the limit as x tends to 0. Since you have the sin square x, you have the x square, you can group these two. This tends to 1. So the remaining terms are the limit x tends to 0, it is 2 tan x. If you apply the limit, the tan x is 0, 0 into 2 is a finite term, you will get this 0. In the left part, you interchange the log with limit, limit of y as x tends to 0. Since you have the log with base e, you can take the term to the RHS part. Limit of y means you taken the y as the cot x power sin 2x as x tends to 0. This equals e power 0 equal to 1. That's the answer. The next problem, limit of sin x divided by x power 1 by x square as x tends to 0. First you apply the limit. You know the property limit x tends to 0, sin x by x, you can take the term as y. Don't apply the limit separately, the sin 0 and divide by 0. So directly apply the property for this full term, sin x by x, limit as x tends to 0, you know the property is equal to 1. So this tends to 1, then 1 by 0 you will get the infinity. So the given indeterminate form is 1 power infinity. Then as usual you consider the given term as y, take the log on both sides, then apply the limit, then apply the L'Hospital rule. So the first term, I consider this part as, let's do step by step. Take this term as sin x divided by x 1 by x square. Then take the log on both sides. Log y equals, apply the property 1 by x square log sin x divided by x. Then as usual, apply the limit on both sides. Limit x tends to 0, log y, as x tends to 0, this equals limit x tends to 0. Here you apply the property sin log m by n property, log sin x minus log x divided by x square. Then soon after this you apply the limit for the RHS part. So the limit is, here only you apply. So here as you take the limit x tends to 0, this part sin x divided by x tends to 1, then log 1 you will get the 0. Denominator you have the x square, this part equal to 0. Or simply you can also apply for this sin 0 and the log 0, you can apply. Better you apply for the previous term, you will get the property. So you will get the indeterminate form 0 by 0. Then you can apply the L'Hospital rule. After apply this logarithmic property by L rule equals limit of x tends to 0 log sin x differentiation 1 by sin x, and sin x differentiation is a cos x, minus log x differentiation 1 by x, denominator x square differentiation 2x. First to simplify this part by taking the LCM. If you take the LCM, x sin x is the LCM. First you take the LCM, then apply the property. So the limit of x tends to 0. Here the LCM is x sin x. Numerator, cross multiply this, the x cos x minus sin x. Denominator you have the 2x by 1. You can also write it as 1 by 2x. First to simplify this, then you apply the property. So limit of x tends to 0, x cos x minus sin x, denominator to x square sin x. Since the denominator you have the product between the polynomial and trigonometric, and you have the sin x of course, then since you have the limit x tends to 0, you can apply the property in the denominator. So here, since you have the sin x, multiply and divide by x, then this term tends to 1 using the property. Then simplify that, then it tends to another indeterminate form. Again apply the L'Hospital rule, you will get the answer. So this equals the limit of x tends to 0, it is x cos x minus sin x, denominator 2x square into x, you will get the 2x cube. Again it tends to indeterminate form. Since x tends to infinity, you will get the 0 by 0. Again apply the L'Hospital rule. Limit of x tends to 0, x cos x, you apply the product rule. First term, differentiation of cos x is a minus sin x plus x differentiation 1, keep the second term cos x as it is, sin x differentiation minus cos x, denominator 2x cube, the x cube differentiation it is 3x square. The plus of cos x and minus cos x get cancelled. You cancel the 1x. So you will get the limit minus sin x divided by 6x. Again apply the property sin x by x as limit x tends to 0, this term equal to 1, and the LHS part you interchange the log with limit. Log limit of y as x tends to 0 equals minus 1 divided by 6. Since you have the log with base c, again you take this to RHS part, the limit y as x tends to 0 equals e power minus 1 by 6, 1 by e power 1 by 6. Then substitute for y, it is sin x divided by x power 1 by x square as x tends to 0 equals 1 by 6th root of e power 1 by 6, it is 6th root of e. Similarly, you can write the limit of tan x divided by x power 1 by x square, you will get the another answer. Next problem, limit of x tends to 0, a power x plus x power 1 by x. So first you apply the limit as x tends to 0, a power 0 is 1, 1 plus 0 you will get the 1. Again 1 by 0 is infinity. So the given indeterminate form is 1 power infinity. First you take the given term as y, let y equals a power x plus x power 1 by x. Then take the log on both sides. Log y equals 1 by x log a power x plus x. I apply the property log a power m, m log a. Then take the limit as x tends to 0 on both the sides. Log y limit of x tends to 0 log a power x plus x divided by x. Then apply the limit as x tends to 0 again. For the numerator, a power 0 is 1, log 1 is 0, denominator is also 0. So it is 0 by 0 form. Then apply the L'Hospital rule for the RHS part. By L rule, the limit of x tends to 0, here log x differentiation 1 by x, 1 by a power x plus x, differentiate the a power x into log a, differentiate x, you will get the 1, denominator x differentiation, again it is 1. Then apply the limit equals limit x tends to 0, a power 0 is 1, you will get the log a and you have the plus 1, denominator a power 0 plus 0, a power 0 is 1, you will get the 1. This part is equals log a plus 1. In the left part, you interchange the log with limit. Limit of y as x tends to 0 equals log a plus 1. Since you have the log with base e, you can take the log to RHS part. So it is limit y as x tends to 0 e power log a plus 1. You can spread the exponential power. It is e power log a into e power 1. Since you know the property e power log a can be written as a, you can write this term, this part as a. You rewrite this term, the limit of y as x tends to 0. Since you have the property e power, log a can be written as a. Next, substitute for y, it is a power x plus x power 1 by x as x tends to 0. This equals a into e. This is the answer. The next problem, limit of a power x plus b power x c power x denominator 3 power 1 by x as x tends to 0. First to apply the limit. So if you apply the limit as x tends to 0, a power 0 is 1, b power 0 1, c power 0 is 1. So 1 plus 1 you will get the 3, that cancel with the denominator. So we will get the term as 1, then 1 by 0 is infinity. So take this term as let y equals a power x, b power x, c power x divided by 3 power 1 by x. Take the log on both sides. Log y equals 1 by x log a power x, b power x and c power x divided by 3. Then apply the limit as x tends to 0 on both the sides. Limit of x tends to 0, it is log y equals limit of x tends to 0. Here again apply the logarithmic property log m by n. So you will get the log a power x, b power x and the c power x minus log 3. Denominator you have 1 by x, so the denominator will get the x. Then apply the limit, check whether it takes a standard indeterminate form or not. So the first one as x tends to 0, you will get the a power 0 1, b power 0 and c power 0 is 1. Then log 3 minus log 3 you will get the 0, denominator is also 0. So the given problem takes a standard indeterminate form 0 by 0, then you can apply the L'Hospital rule. So this equals limit, you keep it as it is, limit x tends to 0, the log x differentiation is a 1 by x, I write it here. Limit of x tends to 0, log x differentiation 1 by x, then a power x differentiation, a power x into log a, b power x, log b, c power x log c minus the log 3 is a constant term, the differentiation is 0. Denominator you have x, the differentiation of x is 1. Then apply the limit, you will get the answer. So the limit as x tends to 0, first part 1 by a power 0, b power 0 and c power 0, you will get the 1 plus 1 plus 1, you will get the 1 by 3 as the answer. Similarly second part, a power 0 is 1, keep the log a, b power 0 and c power 0 is 1, you will get the log c. Left part, you interchange the log with limit y as x tends to 0 equals 1 by 3 times. You have the property log a plus log b and plus log c can also be written as log a, b and c. Since you have the multiplication of 1 by 3, then apply the logarithmic property m log a. You can also write this term as log abc, it is log a power m. In the left part, you have the log with limit y as x tends to 0. Since in both the sides you have the logarithmic, neglect the log on both the sides. Then you can write this term as limit, substitute for y, it is a power x and b power x plus c power x divided by x power 1 by x as x tends to 0 equals, if you neglect the log on both sides, this is how the power 1 by 3, you can write this term, it is cube root of a, b and c. This problem is depend on the number of constants. Since you have the 3 constants, you will get the cube root of ABC. So similar as the previous problem, I have the next one. Limit as x tends to infinity for this problem. Then 1 power 1 by x, 2 power 1 by x, 3 power 1 by x, denominator you have 3, power 3x. As usual, first you apply the limit, check whether it is an indeterminate form or not. So the first one, here, since you have the x tends to infinity, 1 by infinity is 0. So 1 power 0 you will get the 1. Again the second term, 1 by infinity is 0, 2 power 0 is 1. Third one, 1 by infinity is 0, 3 power 0 is 1. So 1 plus 1 plus 1, the 3 denominator you have the 3, you cancel both the terms, you will get the 1 within bracket. So the next one, 3 into infinity is infinity. So you will get the 1 power infinity is the form. Next, as usual, you take the given problem as y. Let y equals 1 power 1 by x, 2 power 1 by x, 3 power 1 by x, denominator 3, power 3x. Then apply the log on both sides. It is log y 3x log a power m property m log a. It is 2 power 1 by x, 3 power 1 by x, denominator 3. Then take the limit as x tends to 0 on both the sides. Limit log y as x tends to 0 equals limit of 3x log 1 power 1 by x, 2 power 1 by x, 3 power 1 by x, denominator 3 as x tends to 0. Then again apply the limit, x tends to infinity, x tends to infinity, apply the limit, 3 into infinity, you will get the infinity. For the second term, again it is 1 power 0, you know the 1 by infinity is 0, 1 power 0, 2 power 0 and 3 power 0. You will get the 3 divided by 3 log 1, the log 1 is 0. So 1 power infinity is reduced to infinity into 0. Then what you have to do means, so write any one of the term to denominator. So write this x to denominator and apply the logarithmic property for this part. So limit x tends to infinity, keep the 3 as it is, apply the logarithmic property, plus 2 power 1 by x, 3 power 1 by x, minus log 3, denominator. So I write the x to the denominator, you can write as 1 by x. If you apply the limit as x tends to 0, again you will get this log 3 minus log 3 will get the 0. Denominator 1 by infinity is 0. So it reduces to standard indeterminate form. You can apply the L'Hospital rule by L rule. So differentiate the numerator and denominator separately. So you will get the limit of x tends to 0. Keep this x tends to infinity, keep the 3 as it is. Log x differentiation 1 by x. So 2 power 1 by x 3 power 1 by x. Next, differentiate 1 power 1 by x. It's same as the previous problem. A power x differentiation, a power x log a. The same case, differentiate 1 power 1 by x. So 1 power 1 by x into log a means write the log 1. Then you have to differentiate this 1 by x again. So 1 by x differentiation minus 1 by x square. Same, the second term, 2 power 1 by x log 2 minus 1 by x square plus 3 power 1 by x log 3 minus 1 by x square. Log 3 differentiation 0. Denominator, since you have the 1 by x, the differentiation of 1 by x is minus 1 by x square. This one. Since you have the minus 1 by x square is common, you can take this term outside, then cancel with the denominator. So this equals the limit of x tends to infinity. So keep this 3 as it is on this denominator part, 2 power 1 by x plus 3 power 1 by x. Take the minus 1 by x square outside. First term 1 power 1 by x into log 1. Second term 2 power 1 by x into log 2. Third one 1 by x into log 3. Denominator you have minus 1 by x square. So cancel these two, then apply the property, cancel minus 1 by x square, then apply the limit as x tends to infinity, you will get the answer. So this equals, apply the limit, 3 divided by 1 by infinity will get the 0. So 1 power 0 is 1 and the 2 power 0, 3 power 0 will get the 1. Then here again the 1 power 0 will get the 1. So keep the log 1 as it is plus log 2 plus log 3. So 1 plus 1 you will get the 3 in the denominator, cancel with the numerator. The left part you have the log with interchange the log and limit as x tends to infinity. Here apply the logarithmic property, log a plus log b plus log c can also be written as log abc. So it is log 1 into 2 into 3. Neglect the log on both the sides. Then substitute for y, you will get the limit 1 power 1 by x, 2 power 1 by x, 3 power 1 by x, denominator 3, power 3x as x tends to 0, answer as 6. This is the answer. Thank you.